Alright, ladies and gentlemen, this is lesson 4, inverse trigonometric ratios and solving for missing angles. Khan Academy did not have a very good selection of videos when it came to this, so I want to make sure that you're good on solving for missing angles. So one of the things that you may or may not have done in the past is, in your lessons thus far, is look at your calculator and make sure that it is in the right mode. So if you hit mode, which is the button just to the right of your second button, and you look, most of the time you're in radian mode, and so we want to move to degree mode. So you're going to go down and highlight, and when you have it highlighted, you want to hit enter. This is one of the things that you need to remember, that when you're doing trigonometry or when you're doing any kind of geometry type things, especially like for the ACT, you need to make sure you're in the correct mode. In Algebra 2, you'll learn about radians. Radians are just a different way to measure the size of an angle. So you need to make sure your calculator is in degree mode right now. Alright, so we're going to look at inverse trigonometric ratios. That's going to use the calculator, and then we're going to also solve for missing angles. But before we get started, I want to make sure that you all are good on sine, cosine, and tangent. So remember that sine has a set of sides that belong to it. The sine ratio uses opposite over hypotenuse. The cosine ratio uses adjacent over hypotenuse, and the tangent ratio uses opposite over adjacent. So what I'd like you to do is just kind of review this. You can do this on a little piece of paper or in your notebook somewhere. I want you to write what the sine, cosine, and tangent ratios of this triangle are for angle T. Alright, if I'm looking at angle T, that means that this is angle theta. Remember, theta is just like a variable. It's an x. And so I'm looking all the way across the triangle is the opposite side. So 7's on the opposite side. Right next to my angle is the adjacent side. And the hypotenuse is always across from the 90-degree angle. So I need to make sure I know those sides before I even jump into sine, cosine, and tangent. So I usually label A, O, H, and then that way when I'm ready to set these up, then I have all the pieces that I need. So sine is opposite over hypotenuse, so the opposite is 7, the hypotenuse is 25, so this is 7 over 25. Cosine is adjacent over hypotenuse, so 24 over 25. And tangent is opposite over adjacent, so 7 over 24. Now, what we're going to do in today's lesson, we're going to review just a little bit more just to make sure that you're good on this. But in today's lesson, we're going to have the sides, the two sides. We need to find the angle, and so I'm going to show you how to do that. So if you wanted to know what angle theta was, you could use one of these, or you could use all three of them. They should come up with the same answer. To figure out, calculate what angle is this measurement really at. Alright, let's do a couple more review though, make sure that we can solve for the sides, and then we'll look at solving for the angles. So I want you to pause the video right now and figure out what x is for both of these problems. Alright, for this problem on the left, I'm going to identify my side. So this is across the triangle. I have to kind of think of it like here, like this. This is the right angle, so this is the hypotenuse. I'm going to put an H here. And this is opposite, so this is going to be O. So if you need to flip the paper around to look at the triangle a little bit better, you can do that. So I have opposite, I have hypotenuse, so I have to make a choice. Is it sine? Is it cosine? Is it tangent? Well, opposite and hypotenuse is sine. So sine of my angle equals opposite over hypotenuse. And I'm going to fill in what I know. I know two things. I'm going to be looking for the third one. So sine, my angle is 67 degrees. Opposite is 24. Hypotenuse is x. Now what I like to do is I like to put this over 1 and I like to cross multiply and then solve for x. So if I multiply this way, I get x times sine of 67 degrees equals 1 times 24 is 24, and then I'm going to divide by sine 67. I like to wait to put sine 67 into my calculator at the very end because of all the decimal places in the rounding. So now that I'm in degree mode, I'm going to type in 24 divided by sine of 67, and I get 26.07. Now we don't know what this is a measurement. This is a side length, so this is not degrees. So this could be feet, this could be inches. Alright, let's look at the one on the right. Again, here's my angle. I have to determine what my sides are. So all the way across the triangle is opposite, and right next to the angle is adjacent. This across from the 90-degree angle, this is hypotenuse. I don't know my hypotenuse. If I wanted to find it once I have my adjacent side, I could run the Pythagorean theorem. But right now I'm just focused on what is x. So I have opposite and adjacent. Opposite and adjacent is tangent. Tangent of my angle equals opposite over adjacent. Alright, so let's plug in what we know. We know our theta is 28 degrees. Opposite is 12. Adjacent is x. I'm going to put this over here. I'm going to cross multiply. So I get x times tangent of 28 equals 12. So x is 12 over tangent 28. So let's pop that in the calculator. 12 divided by tangent 28. 22.57-ish. 22.57. Again, that's a side length, so it could be feet, could be inches, could be miles. We don't know what it is, but that is the side length for our adjacent side. Alright, let's look at the lesson piece that we're going to talk about here. Alright, inverse trigonometric ratio. So I told you we're looking for the angles. So I want you to look at your calculator. I'm going to clear this out. Look at your calculator and see sine, cosine, and tangent. Right above them, you have sine to the -1, cosine to the -1, tangent to the -1. Okay? These are our inverses. Inverse trig functions. What they do is they undo our actual trig functions. So just like when we square something and then square root it, the square undoes the square root, or the square root undoes the square, that kind of opposite function. So what we're going to do is we can't divide by sine. You're just not allowed to. You always have to take sine of something. So what we're going to do is we're going to take sine inverse of both sides. Whatever I do on one side, I have to do on the other. So when I have to use, if this is sine, I have to use sine inverse. Cosine, I'll use cosine inverse. Tangent, I'll use tangent inverse. So you have all three. But what you're going to do is you're not going to focus necessarily on this side because this undoes this. This tells me A equals. What I'm worried about is what is this piece. So I'm going to put that in the calculator and I'm going to hit second sine and just 7 divided by 10. And this tells me how many degrees my angle is. So 44.4 degrees is what angle is. Angle A is. Okay, so you just have to know which one to use and when to use it. You use this when you're looking for an angle. If you have the angle, you don't have to use this. You don't have to use your inverses. So your little inverse keys are for finding angles. All right, so let's see. We see cosine. We're going to use inverse cosine. Okay, so I'm going to come over here and I'm going to hit second cosine and 4 divided by 5. And it's going to tell me the angle of theta is 36.87 degrees. So theta equals 36.87 degrees. Alright, so I want you to try tangent just by yourself, see if you can get the hang of it, and see if you can figure out what x is. Pause the video and figure out what x is here. Alright, so hopefully you use tangent inverse on both sides. Alright, so second tangent, 24 divided by 7. I get 73.74. So x equals 73.74. Alright, so that's just a little bit of calculator work. These pieces were already set up for us, just to kind of give you a feel for what was going on in how to solve for these variables. So let's look at some examples where we have to find the missing angle. Alright, so this is examples 1 and 2. I'm going to actually stop this.